And we're going to, ladies and gentlemen, close the speaker lineup of today with the joys and opportunities that the photogrammetry enables. So, delight in photogrammetry, let me bring on stage the last speaker of today, the founder of RichPix, Barry Bassnett. Please, Barry, join me on stage over here. Let's give it up for Barry. Woo-hoo-hoo. Barry, welcome.
Thank you.
Enjoy the spotlight.
Hi guys, wow. Hasn't it been great so far? I'm sorry, Michael, you've been really mean putting me, the oldest person, on last, because it's way past my nap time. So I'm going to be, the title of my thing is The Delight of, Delight of Photogrammetry, and it's a play on words because what I'm going to talk to is about the process of delighting, but also, this is just so much fun. You know, I think we forget sometimes we have a fantastic job and we get to play with amazing kit. And then you see displays like we've seen from our underwater friends and Naira and Ted's thing this morning that blew my mind about why can't we get Skydio in Europe, please? Anyway, that's another story. So I'm going to be talking about, well, I'm an advocate for cameras. That's why I've got one here. It doesn't have to be a fancy camera like this. It could be just my mobile phone. And we forget that these are fundamental tools for what we can do. And imagery is so much part of most of the workflows. So this is me. Okay, this is not me shrunk. This is not Who Shrunk the Photogrammetrist, because that's what I am. Most of my stuff that's my kit. I travel around the world now training people on photogrammetry. Well, that's what I try and do anyway. I've been working in photogrammetry for, since the Jurassic period, I think. I am an analog guy. I was the guy who used to take photographs with film, sit in the back of planes throwing up, take all my developing chemicals with me, make up a dark room in my hotel room or whatever shed I could find. But now we've got our digital stuff, and I've moved from training as a photogrammetrist, a cartographer for 10 years. And then I moved into industrial photogrammetry, where I worked on projects like the International Space Station and weapons systems alignment for jet fighters. Because the interesting thing is the same technology that you're using now has been used in industrial metrology for many years. And people are only discovering it. Oh, sorry, I've gone the wrong way. Okay, so I go out and do training. So I've just come back I was in New York at the Met training people on how to, they've been photographing for 120 years, but now they're moving into 3D modeling. But they've got a fantastic imaging suite, but what I do is for the things that are too big to take into the imaging suite where you can control the lighting, I take that and teach them how to photograph big stuff. And the problem with photographing big stuff is, well, basically you can see in here, we've got all sorts of different sorts of lighting conditions. And what I do, and what I try to do is, as you look from the back, my thing's Shadow Buster. What I try and do is try and eliminate the shadows from imagery, because shadows hide data. Now, it turns out that shadows are not quite as important as highlight. Sunshine is the thing that kills photogrammetry. But what I try and do is show people how they can get around that. And this is the team from the Met. That's me in the middle, of course, looking svelte and young. Okay. But we've got, these guys have just, they've been taking photographs for 120 years. These are the best in the world. But we had a great time sharing experiences and moving things on and taking photographs. And what I want to try and do is explain that imagery is at the core of what we do. In this case, it's just simple things like changing a color image to black and white can change the way that we look at a job, how we use it for inspection. But I'm going to talk about a particular project. But first of all, I want to do something and try and do something that no one's ever done before. So I'm a photogrammetrist, but I'd like to rebrand myself in my middle age, at the end of my career, into what I call spatial imagery. Because we're taking photographs, but we're using photographs in so many different ways nowadays. So we use it for photogrammetry, obviously, but photogrammetry can be drone-based, it can be terrestrial-based. We can take it from the satellite, we can take it from a drone. We've also used 360 imagery. Much more has been talked about using 360 imagery. We've got things, if I'm being honest, guys, I haven't really learned much from the geomatics industry in the last 10 years. Most of what I've learned about processing imagery and making colors and calibrating and all sorts of things has come from the IBL, image-based lighting, film and effects business. So I've been adapting those things. I invented a term called 32-bit photogrammetry, which is, it's really HDR, but everybody's hijacked that. So I wanted to change it to something. We're using imagery in all sorts of geo-based, geo-tagged imagery, whether it's a camera with an RTK system, or we're just walking around taking photographs of assets and stuff. Am I looking here? Okay. There's a time clock here. Okay, I'm just 14. Okay, that's fine. And then we've got photogrammetry, also about point cloud colorization. I mean, I love LiDAR, but I haven't used LiDAR for ages. Because what we're doing is we're colorizing our point clouds with shadows and highlights and colors that change intermittently. And what I try and do is try and show people how you can make neutral imagery, how we can then light it, because we're burning textures and colors into models that don't exist, or they exist for a fleeting moment. And then we've got using photogrammetry and remote sensing in GIS and all those sort of things. But all of these require one particular thing. And lastly, Gaussian splats. Now, 2 years ago, this was like, who'd heard of them? But now, I'm looking at it, and I feel a bit like that dinosaur looking up at the big round thing getting bigger and bigger. Because as a photogrammetrist, people tell me Gaussian splats are going to make me extinct. Well, I'm not so sure about that, but it is just a fabulous technology. But the key thing about all of these, and what I call spatial imagery and not photogrammetry, is all of them require one thing. They all require us to be able to look at a simple thing. What has changed? That's what we're doing with imagery. What has changed? What colors changed? How a product is, how a material is dilapidated or deteriorated. And to do that, we need to look at its color, its shape, and the condition of things. And we use imagery to do that. We don't necessarily use LiDAR data unless it's a geometric shape change. Oops. And a lot of people say this process of, I hear the phrase rubbish in, rubbish out. I prefer to rephrase it and call it quality in, quality out. Because that's what we're trying to do. And rubbish in, rubbish out is certainly a negative phrase. I prefer to go some more positive. And it's about actually thinking about the process that you need when you're using imagery in your workflows. So when we're talking about image quality, what exactly we're talking about? We're talking about the correct color. And color changes during the day. We get this thing, so we get the golden period, the blue period, noon. It changes with the seasons, with the angle of the sun. We get different colors depending on the lighting. We're also looking at, and we're going to talk about that in a video I'm going to show shortly about a project I've been working on. It's also about focus, getting things sharp. Blurry images and stuff, we can't work with those. The algorithms, the SIFT algorithm we're all using in photogrammetry, ironically blurs the image but if it blurs, it doesn't work. We need to look at the thing that probably kills most photogrammetry, this idea of luminosity, dynamic range, the brightest sunshine reflecting off a white surface, the darkest shadow, okay? And then we've also got the one that's not known. I mean, a lot of people talk about using sliders for shadow enhancement and things. Well, they forget it's the midtones, the contrast that make your models pop. That's what make your models look alive. And it's the colorization and the textures that you apply which makes a flat model that looks obviously unreal into a live thing that engages the audience and makes it look real. Okay? And the other thing that we've got to be careful about is image consistency. In the Northern Hemisphere, from the 31st of October to the 31st of March, round about then, the north side of any building is not lit by direct sunshine. So we have to think about consistency of lighting, consistency of color for all these beautiful algorithms to work. Image consistency, and that's what I try and, that's what my mission is to try and help people get their images consistent. But before I move on to that, there's a really important thing as well. Image management is just not about the quality of the image. It's also how you manage them. Last year, I had to process 1.5 million photographs. Okay, I have to be able to find it. We've got billions of photographs, and the other thing I'd like you to take away from this is to think about findability. How do I find the right photograph? And this is really important in all our workflows. You know, where is that photograph that I took? When was it taken? So, where was it taken? Where on the planet? Where inside a building? Okay, when was it taken? Because I need to be able to compare things so I can see what's happened and what's changed. But probably one of the more interesting things is, what is it a photograph of? How do we tag these photographs? And this is becoming much more important in things like asset information management or asset management, and even simple processes like if I'm doing a photogrammetric project, as I'll show you in the cathedral, I need to be able to find which is the relevant photograph. Okay, so, and you see here, this is a typical sort of example you have to deal with. Photogrammetrists all over the world will say, oh, you can't do that. You can't make a model from this because of the shadows and the windows. Well, actually, you can. Okay, and this is and how do you do something like this? This is a window, stained glass window in the Met. It's really interesting, this, because it changes shape and color as the light goes through it. The leaves turn, the buds turn to flowers, depending on the angle. How do you capture that? Well, you've got to be able to do things, and that's sort of an example. So can I have the video? Can you play the video for me? So this is me. And this is a project I've been working on since last August. It's the Westminster Cathedral in London. It is a huge building with a huge amount of dynamic range. You see the brightly lit areas, you see the dark areas. And the brief was that they want to, there you go, that's me. You can see the difference between the light and that's just from a normal camera. Okay? I had to use lots of different ways to gather this because the spec was they wanted every single service documented. So I used a number of different techniques, different cameras. But the key thing I had was this, because I have to calibrate every single image for color. And these are the sort of things, every single inch of the ground floor is covered in these little tessellations. I had the use of a fabulous camera, a phase 1, which is 150 megapixel, and we took 3 bracketed images for each one. And this is just one thing. So this is an ortho image of just one of the chapels that we took. Okay, so this is taken, and we are getting a resolution. They asked for a resolution of 1 millimeter per pixel. We're getting, on average, 0.19 of a millimeter per pixel, but in some areas it's much, much better. And the reason they need this is because of the Notre-Dame fire. They want to document everything just in case there's a damage so they can reproduce it later on. So it's an insurance document. It's also a tool that shows them where are these little tiles. If I pass this, can I give this to you? This is an example. If you want to pass it around, these are the tiles, the little tessellae. They're about smaller than my little fingernail. And we had to photograph all the surfaces in this cathedral, which has taken me from August to finished the last photographs about a fortnight ago. Not every day, obviously, but you can see here on some of this bit around here, you can see that it's not flat, it's curved. So this is a dynamic record of everything that's of every single surface. And the author photographs with our friends down there who did the previous thing. But we also documented it with what we call smart 360s as well. So a smart 360 is like, we're going to talk about Matterport in a second, but it's like a 360. And this is the view from the organ room, the organ loft. Now, you can see the surfaces. There's all of these surfaces. There's 129 different types of marble in this. One thing, don't try scanning any marble with any scanner because it doesn't give you a flat surface, okay? So this is all, it's pitch black when you look at a normal camera, but we're able to look into with the 360 imagery, we're able to just use 360 imagery, which costs 5 grand, 5,000 euros to do. I don't need a scanner to do this, because we are using the imagery to do inspection, not necessarily a model or a mesh model. Okay? Now we're going to zoom out a sec. So it looks pretty good on that screen, doesn't it? Yeah, anyway. It looks, yeah. This is the same thing done with Matterport. Okay, and you see the difference. Matterport is a great tool, but it doesn't give you the RichPix way. My way of doing it uses HDR. And this is another example of, this is inside a chapel. And the interesting thing about this is this chapel's not lit at all. So people coming in, and they can't actually get into this chapel because there's lots of railings around it, because I was lucky enough to get in there. But this is a small room. It's no bigger than this, well, half the size of this stage. But we're able to do this with no lighting using some simple technology. It's not hard. I could teach anybody in this room to do it in the morning. It's not hard, but we're not using this to colorize our point clouds. Okay? We think we have HDR, but not necessarily. This allows us to choose, and all of these images are calibrated for color. So in the future, if anything happens, they can match it pixel for pixel, color for color, for every single tessellite. Yeah, and so this is the Vaughan Chapel, if anybody's in London. I'd recommend, you can't get in the cathedral at the moment because of things that have happened. It's just public. And this took me, it's a lot to do, because you have to negotiate around all the people who are attending, because it's a public building. You can't stop it. You can't shut it off. So we're able to de-light it and then relight it again using some simple technology. As I say, it's not hard to learn how to do it. I just like, yeah. And this was done actually, this wasn't done with the phase one. This is just something done with my Sony camera, this particular shot. Okay, can I have those slides back on again, please? Okay, so this is my final slide. This isn't a photograph. This is a model. This is a mesh model of one of the chapels. And what I really wanted to do is just show and talk about the problems that we've got and what we can do with simple technology, our cameras. We don't need, well, to be fair, just to put it into perspective, all of this building was scanned using LiDAR, and I used the LiDAR point cloud for my control. But every single surface that's decorated in this place has been photographed now. So that's really what I wanted to talk about, basically, I'll show you a couple more slides that I've forgotten I had, actually. Sorry about that. So this is the difference between, say, if I go back, so this is a normal scan. This was actually done with a Regal scanner, Regal 600. Okay, but because they have a process for HDR lighting, they can change it to a real color. Okay, and this is the sort of model you can get if you know how to light it. This was done with a mixture of Regal scanner and drone footage. But the problem and the challenge there is, how do I get consistency of color when I've got a camera drone, I've got the camera in my scanner, I've got an external camera to balance it all out. And that's the process we call, well, what do I call it? Yeah, RichPix. It's our technology that we use. And as we said, we can teach anybody how to do this, but I think you can see this. This looks like a more realistic model. This is a point cloud, of course. Okay, and just as a final thing, I'd like to say about photography. I'm on a missionary work here. Basically, I think photography is going to be the most single important skill that everybody in this room needs to master. Because as we move to the world of Gaussian splats, as we move to the world of laser scanning, it's the image quality that is going to define how realistic we are. Whether that's high dynamic range, the shadows, the highlights, the true color, the true textures. We've got great tools for capturing geometry. This will help us to capture reality. That's all I wanted to say. Thank you very much for your time, everybody. Look forward to Getting loads of questions. What I should say is if anybody's got any questions, my business is actually training you guys. And if you give me a call tomorrow, I work for free on Fridays. I have done for a number of years. But if you want to get in touch, ask me any questions about it, find out more about this process and how we can take your skills to another level, not sound patronizing, but give you something else to think about, please drop me a line. Okay, thank you very much for your attention.
And gentlemen, a massive applause for Barry. Barry, that was incredible.
Thank you.
That was incredible. A lot of questions, actually, that came through.
Okay.
So let's start with a personal one. What was your favorite project so far?
This one. This is the hardest single project I've ever done in my life. I'm lucky I've worked in some great places. I've worked at Petra, I've worked at all sorts of lovely places. But this has to be the favorite one. It was a really moving experience working in that community for that period of time. But also, this was a project of 10 million mirrors. All those little mosaic tiles are just mirrors. Some are gold. And the difference in dynamics was just really, it made me think. And it gave me so much material I can pass on to you. So you don't have to make the same mistakes I've made for 45 years.
Talking about the mistakes, a lot of people are asking whether you can teach them the skills. What's the best way to reach you? The address?
Just the email address, or find me on LinkedIn.
Can you please flash it back?
Yeah, okay.
Perfect. Let's flash it back. So, yes.
Just take a photograph of it. A lot of you will know me from LinkedIn anyway, where I hang around. And I think I'm on tip 58 of my photogrammetry tips, and there's some sexy ones coming.
Fantastic. One more question.
Okay.
How did you deal with the areas that were gilded or shiny in some way?
Okay, so we use a technique called bracketing. So I'm taking multiple exposures and then aligning them and then processing them, turning them into what we call a 32-bit file format, EXR, and then doing some tone mapping. And that sounds complicated, but it's really not. I've developed a simple way of actually leading you through the process, batch processing, so you don't have to sit there and do every single image yourself. It's an interesting way, but it's something I learned from the film business and the FX business, and I've transferred it into reality capture.
Brilliant. Ladies and gentlemen, one more round of applause for Barry. Barry, thank you so much.
Thank you.
Thank you.
I'll see you in the bar, guys.